Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is from a conversation I had with University of Maine Distinguished Professor Ivan Fernandez in late August, before the semester really kicked in for him. We covered a lot of topics, but they all have one common theme: how Ivan's work and mentoring advance science and science-informed policy issues for Maine. Ivan has been working with the Maine Climate Council and also provides a great explanation of his job at the University of Maine, especially with regards to research and mentoring undergraduate and graduate students. I've included links in the show notes to Ivan's UMaine page, as well as Maine's Climate Future, the report Ivan mentions, and the Maine Climate Council. I hope you enjoy the conversation. Ivan, welcome to the Maine Science Podcast. I was hoping that you could tell us a little bit about what you do right now, and then we'll dive back into how you got there.
Well, I'm a professor at the University of Maine. I've been there for a very long time, going on 38 years. I'm a soil scientist by training. I'm a biogeochemist of ecosystems to take it sort of to the next level. I teach classes, teach soil science and other classes. I do a lot in environmental issues related to ecosystems and the biogeochemistry of ecosystems, having to do with more local issues of solid waste management and residual land application, but a lot of time on things like acid rain and climate change, and spend a considerable amount of time also in trying to make linkages between the science and management and policy.
I definitely want to circle back to that. My previous life was in policy work. But before we do that, I would hazard a guess that most people don't think of soil as a science area.
Yep.
So how did you get into that? And if you could just explain a little bit what it means to be a soil scientist, at least for you.
Sure. So you're absolutely right. I've spent my entire career when people say, what do you do? And I finally, if I say environmental scientist or I'm a climate scientist, then they're like, their eyes light up. If I say I'm a soil scientist, they're like, huh? And starting all the way back with my in-laws from many years ago, they were like, what's he do? Soils are kind of what you think they are. I mean, most people think of soil as being the stuff right at the surface in your garden or in your front lawn, which it is, of course. The soil scientists are going to think of soil as being sort of the layer above bedrock, the ground up material. And it's really the interface between the atmosphere, the biosphere, and the lithosphere, which is the atmosphere, living organisms, and then the bedrock geology beneath. But it's that thin layer of soil that really is what connects it all. And so we map it, we study its physical, chemical, and biological properties. It's important in agriculture. Obviously, it's important in forestry. It's a raw material. If you know pottery in China, it's the fine clays that are produced from soil weathering are the raw material that we fire in kilns to make pottery. People know of vermiculite. That's another secondary soil mineral that we use in packing or potting material, et cetera. So soils ends up being kind of a lot of stuff that people don't think about. And yet it impacts every part of our life. If you have a septic tank out back, then you've got a leach field, and soil scientists had to figure out, how to design that. Obviously, in agriculture, farmers are professional soil scientists, whether they call themselves that, which they usually don't, or not. And so it's a wide range of issues, and some of what I've done in my own work has to do with environmental issues. And so things like if we land apply ash or a biosolid, what happens? How much can the soil take? And in acid rain, the impacts of acid rains on particularly freshwater lakes and streams was the concern, and the fish that live in them. And almost all of the impacts in those freshwaters had to do with what the soil did to the raindrops as they migrated through a watershed before they got to the lake. And so for those that know this, more about the acid rain story, it killed fish. And that was a concern. And the reason it killed fish was because the acids fell on the soils in the watershed, dissolved aluminum got on fish gills, and then damaged the gills, and basically they suffocated. So it's those kinds of things that have always really intrigued me. So what are the mechanisms, and how is soil a part of that from the biological, chemical, and physical standpoints?
Was soil your focus when you were 7?
No.
How did you get to that?
Almost no one I've done this a long time. I've been the soils guy, so people tell me a lot of stuff about how soils, what they meant in their life. I haven't had any kids come up and say, boy, that's really what I want to do overtly. Usually, like myself, you're into natural sciences. And so you're interested in studying wildlife, plant communities, forests, that kind of thing. And so that I was a sort of a plant ecologist.
So start bigger.
Start bigger, start the system level. And then at some point along the way, in looking at graduate schools, I stumbled on, one of the different pathways being soil science. And then people talked to me about participating in particular research. And I thought, oh, that is really cool. I never thought about soils that deeply, and kind of the rest is history. And that it went from there. And at the time, when I was starting my sort of graduate career, was the early days of acid rain. And what we were discovering was that, people were concerned about crops and dying forests and fish, but under the hood, it was a lot about soil science and soil biogeochemistry and how that was transforming that pollutant from the sky, both the nitrogen and the sulfur, to change the rest of the ecosystem. And the rest of the ecosystem is kind of the charismatic part that people care about. They want bunny rabbits and eagles and things, which we all do and love. But the mechanism that makes it work often is, I'm biased, has at least a strong component of soil science. And so that's kind of what turned me on to soil science. It's like, wow, how did I miss this?
It sounds like you almost fell into it.
Yep.
Did you grow up somewhere where it was, wildlife and nature were really vital to you? Was that part of what spurred you, do you think?
Yeah, I grew up in upstate New York, so not the city. Kingston, New York.
Yeah.
Where'd you grow up?
Just outside of Albany in Colony.
Oh, sure. Yeah.
So every time you mention acid rain, it was huge. It was a really big deal.
It was the Adirondacks were the epicenter of the effects of acid rain and the most severe impacts on freshwater, on the lakes and so forth in the Adirondacks. And Upper Hudson Valley is where I grew up.
I remember not realizing, I guess, that acid rain wasn't that big of a deal everywhere because it was so big in upstate New York and the Hudson Valley that,
right.
Just between that and the PCBs in the Hudson, right? We were literally surrounded by, in many ways, environmental catastrophe. So acid rain, which we rarely hear about nowadays, and I would argue some of that is because it's actually a science success story because we use the science to figure out how to stop it. And that can be an inspiration on many levels, including climate change, which I know that Absolutely. You have been, you're part of the Maine Climate Council. You've been, I would argue, a science advocate for climate change. So maybe you could talk a little bit about your work with climate change in general, and then the policy piece and why you think it's so important to have the science voice for that.
So you hit on it. I proselytize on particularly issues related to the Clean Air Act that have been amazing success stories, from lead in gasoline to mercury to ozone. Not an amazing success, but we've made progress on ozone. Time and again, when we use science to inform policy, it ends up being a success both in the fact that it provides benefits to society. We make the environment cleaner, we make our health cleaner. And it also over and over refutes the argument that controls in that regard, and it's very relevant to what we're experiencing right now with the rollbacks that are heartbreaking, that it's going to cost the American economy. It does not. Over and over again, obviously we argue about the social cost of carbon, in that context, or, what price to put on a human life, what price to put on a child that has a higher propensity for asthma. Well, those are tough things to do, but we value them. And if you put any value on those, you find that science-informed policy pays back to the American public many times over and over again. I was on the EPA panel that evaluated the report came out, I think, in 2011, the Clean Air Act relative to acid rain, and it paid back somewhere between, it was like a range of between $8 and $90 to every $1 invested, but the median was something around $30. So that means back in 1990, when they said, oh gosh, if we limit sulfur, it's going to ruin the economy. What was really happening was for every dollar we invested in sulfur controls, we got back $30 with much higher in some contexts. And so science-informed policy over and over again. Not every regulation is good. Not every sort of adaptation is cost-effective, I should say, because it may be good if it's really personally valuable to you, then sure, it's good. But if we do the economic analysis, there's a way we do that, and we know how to do that, and a lot of people are really smart about doing that. We find that it pays back. So yes, the importance of using science, people often use the expression science-based policy. I don't think there's any such thing as science-based policy, because the science is presented and then the policy is a political and a social process. And so all of that comes together. But if the boundaries of that decision making are provided by science, then we end up almost always with a good answer. It may not be the most cost effective or the most effective for what some people want, but it's in the right place, and it's always cost effective. Otherwise, we wouldn't end up doing it. So I think science is really important to do that. And I sort of got on that bandwagon early in my career, because when I was first studying things like solid waste locally here in Maine, and they were developing policies at state government around it, I had the opportunity to be part of those discussions. What do we know? What don't we know? What are the risks? And then, sort of more the federal level had to do with acid rain. And I was, part of different panels during the late 1980s that were designing the research programs that were to inform Congress on the Clean Air Act reauthorization, which our own George Mitchell was a leader of leading us through that process, and that came about in 1990, the reauthorization and amendments. And, I've been part of different EPA panels sort of almost ever since. And acid rain is a result of us burning fossil fuels. And some of the pollutants of fossil fuels are sulfur and nitrogen that are released to the atmosphere, and they come back as sulfuric and nitric acid. Acid rain is a regional air pollution environmental issue. And so, as you pointed out, you grew up in New York, you thought everyone must be running around with their hair on fire because, boy, this stuff is bad. Whereas, west of the Mississippi, no one, cared because there was no issue. Well, everything was being produced east of the Mississippi, and it was blowing on the prevailing winds, sort of up the pipeline. But it's the same fossil fuels that created acid rain that we increasingly realized, well, we got a problem because they're also releasing carbon dioxide as a greenhouse gas. And so really, after the reauthorization of the Clean Air Act, the federal agenda on air pollution went through a transition, but migrated to increasingly realize, wow, we've done some good stuff on acid rain, and in Maine, we probably have about 80% less sulfur deposition. So that's why you don't hear people running around about it. And we're doing the research now to show how we see that in our ecosystems. And some parts recover quickly, and other parts are going to take decades and decades to recover. But nevertheless, we're on the right trajectory in that regard. But we haven't done anything to limit greenhouse gases, and particularly CO2. So I began to be involved in some of the discussions, both at the federal level, but particularly in Maine, I became increasingly interested in how climate change, now beyond acid rain alone, was impacting all aspects of our lives. And so, it progressed from there. We did research on climate warming impacts on soils and ecosystems, the interaction of acid rain and climate. Also, in the late 2000s, I became particularly interested in the fact that we had the Intergovernmental Panel on Climate Change, which was the organization that did a global assessment of climate change. And since 1990, every few years, we hear about new reports that they have issued and continue to do so. We've got the National Climate Assessment, which comes out every 4 years, I think. I think IPCC is every 6 years, roughly. But, all decisions are ultimately local. What's happening in our backyard? What should we be doing or concerned with? Or is this just something to watch on TV or on the news about happening somewhere else? And the evidence was pretty clear that it was happening everywhere, including in our backyard. But to make informed decisions in our backyard, we needed to know more about what was happening in Maine. And so I got increasingly interested in trying to define that. And ultimately that led in 2008 to a year-long effort that we launched to assess climate impacts in Maine. And we produced a report, Maine Climate Future. The first one was produced in 2009. 70-some scientists across Maine contributed to that. It was just a sort of a, not to be corny, but kind of a labor of love. Everyone was volunteers. We weren't funded to do it, but everyone came together and worked really hard to produce that, which then at the time provided the legislature and state government with some information upon which to base some policy decisions. And they launched into an adaptation assessment. You know, elections come and go, so the momentum, shall we say, changed. We did another one in 2015, and then we just did another one this winter in 2020. And of course, in the last couple of years, the momentum on climate in the state has dramatically accelerated. So that's kind of the arc of being interested in environmental aspects of particularly air pollution and ecosystems and the biogeochemistry of them. And soils was my gateway to that because of a lot of the action that is happening in the soil. But, you know, they're all sort of connected. A lot of it had to do with how we, land management, but particularly fossil fuel combustions that created these pollutants that ultimately led to a climate focus. And I went from, you know, local to global to national back to local with a lot of my emphasis or my time spent focusing on Maine in the past decade.
So many scientists in the past have been hesitant to enter a foray or be seen as part of the political process. I remember probably 16 years ago, I went to a talk at UMaine by someone who's from Colorado and talked again about all the impacts of climate change. And someone said, why aren't you presenting this in front of Congress? And his response was, well, that's not my job. And it doesn't sound like you've had that problem at all. So why is that?
I'm not sure. I think of it as a problem, but I totally understand what you're asking me. You know, I think there was a earlier period of time where it didn't feel as urgent. And so people felt like I can stay in my bubble and do a good job here and it's going to have an impact. We also went through an era where back in that time, 15 years ago, the environmentalists were saying, don't talk about climate adaptation. If you do, it's going to distract people from focusing on mitigation, meaning don't talk about things we can do to lessen the negative because of the changing climate, because it'll make people think, well, I just need to do these things and I'll be okay. I don't have to stop burning fossil fuel. Whereas we really need to focus on stopping, you know, the use of fossil fuels. And so there was in that era, even among the environmental groups, some reservations about talking about some aspects of how we address climate change across the spectrum. You know, fast forward till now, it's too late. Climate's changing. We are adapting. Sea levels, all sorts of stuff is happening, and most of it's not good. We are responding. We are reacting, and at the same time, the need to respond by dramatic reductions in fossil fuel, essentially eliminate fossil fuel, is a crisis. It's immediately urgent. The IPCC came out with a report in 2018 talking about bending the curve to avoid going over 1.5 degrees centigrade globally average or 2. And the curve that we're on now is still going up, and the curve you need is sort of a right angle to 0 by the middle of this century. So, I think number one, what people were willing to talk about has changed, has migrated over time. Number two, I don't think everyone's cut out to do, we're not, made with cookie cutters. So some people, and I know a bunch of them, are brilliant. I just really, really smart, doing the critical science, But it doesn't mean every one of those that are, up for Nobels are probably the best person to go out to talk to stakeholders in the community or talk to the legislature or talk to Congress. Other people might be on the other side. They go sort of too far, some would say, and the credibility of their science that they're doing it comes into question. Rightfully along, they become a target in that regard. So it takes all kinds. I think the urgency of the issue has forced a lot of scientists to look for ways that they can reach out to make more of a difference in decision making, because we clearly recognize, first IPCC report came out in 1990. It's 30 years later this year, and we haven't done anything really to bend the curve. So it's urgent that we try and make a difference in ways that we think we can. And so I think there's a spectrum of what people will do, but I don't think everyone should be approaching it the same way. I'm a land-grant university scientist, and so we're sort of bred to not just stay in the basement and not tell anyone what we're doing in our labs. We're about interacting with stakeholders and addressing the concerns of the community and whatever it might be. And different sectors like agriculture, working with our cooperative extension colleagues to get the information to you. So we have a pretty rich history of doing that in a land-grant university for sure. And a lot of the climate work I've done is, I think, just an extension of that.
I appreciate you letting me play devil's advocate a little bit there.
Sure.
And also, even more importantly, I think, is highlighting what a land-grant university does. Much like scientists, universities and think tanks and research organizations are not cookie cutters, and there's very different roles for each one. And I think it's really easy to put, colleges and universities in one pocket and not recognize the value of what each one brings separately. So I really appreciate that background. As you were talking, it occurred to me that some of the language you're using certainly was used sort of in March when we had a whole conversation about flattening the curve with COVID. And I'm wondering, I have found, I don't know if it's solace or just naivete or just desperate hope, but part of me wonders if some of the rallying that has gone on in society for COVID-19 and addressing that will then transfer to climate change. And I wonder if that is something that you've thought about. And I realize this is slightly off topic from what we were.
Not really.
I think there's a parallel, right?
Yeah, sure.
I have been advocating personally for quite some time now that, I'm not calling it climate change anymore. I'm calling it a climate crisis. And it feels like that's where COVID was, right? I'm certainly hopeful that we'll have some translation, and I'm wondering what you think.
Yeah, no, I think it's unavoidable to recognize the intersection of COVID and climate change. I think, I've given a couple talks that touch on that. There's a cartoon going around, and it's two doorways with two scientists in front of each doorway. And in front of the one door, it says climate science, and the two scientists in front of it are rolling with laughter. And the other door says COVID-19, and the two scientists, one of them saying to the other, if we just give them the facts, they'll do the right thing. And so the climate scientists are just like, yeah, we've been down that road. That's hysterical. I mean, it's a funny haha, but I think it captures the reality that, the climate community feels like they've experienced, and many that are concerned with it also feel like. I think there's no silver lining with something like COVID from the devastation that we've seen in the loss of life and suffering. So it's hard to talk about silver linings or, in that regard. I do think the issue of the pandemic has a lot of parallels with climate change. I think climate change is bigger, longer, more all-encompassing than the pandemic. It's just right now we're in it, and so it feels, it is overwhelming in that regard. Meanwhile, the climate crisis is still unfolding around us. But the parallels of, using science to make decisions, I've been talking a long time about how we are doing that in some cases, or trying to do that, and why it's important. I think COVID, you can just watch the front page of the New York Times over the last 4 months, and That's the best expose of which states are doing what, and what the infection levels and mortality is as a reflection of that. So science matters. We see the scientific input, we see the ignoring it or utilizing it, but it happens in a very short period of time, so people get it. It's like, wow. And so I think to some extent they'll also say, yeah, we see the same thing about sea level rise, on the coast of Maine, and we see the same. We got 2 hurricanes racing across the Gulf of Mexico right now. Not a common occurrence, predicted as far as the kind of erratic behavior we expect and intensification of behavior, and on and on. I'm hopeful that people will be more open to the importance of that narrative as to how science can inform decision making. I think a lot of the weaknesses in our social fabric, from supply chains, so our food systems, we're dumping potatoes and dumping milk, and we've got more people that are without food and food insecure than we've seen in years. Something's wrong, because the system has migrated to the kinds of inventories and the kinds of supply chains that maximize profit, and I get that, and that's part of the model. But also, in climate adaptation work, you see people thinking through, what are the risks? What happens if? And what do we do to build resilience? This is what happens if, and you haven't built resilience. These kinds of things unfold. The social injustices, who's suffering the most, who's most vulnerable, who's getting the best care based on race, ethnicity, and socioeconomic status. It's not just an academic exercise, and I'm not the academic that runs around talking about it in that context either. But boy, it's clearly evident with this, and it's clearly evident with climate change. The same people suffer the most as compared to who suffer the least. So I think that and the other thing is, COVID has created a human health and economic crisis around the globe. And so with climate, it's doing the same thing. It's just much bigger. It's going to last much longer. It's much more comprehensive, but it's also so comprehensive that it's hard to see on any one day vividly, unless you're standing at sunny day flooding in Portland and Maine, or you're subject to some direct impact. COVID is like, you can't ignore it. Obviously, our lives have changed. And so to move forward, we've got to do something different. And so we've got to invest in recovery. We've got to rebuild our systems. And so now we're really forced to say, okay, do we want to go backwards or do we want to go forward? Because we cannot stand still. We can't just pretend nothing happened and hope we're going to wake up and it's all okay. There's all sorts of things that we need to do to rebuild our economy. We're not out of it. Obviously, there's more to come. And so to work on our health systems and our food security systems, and on and on and on. So I think some have said the silver lining. I really have trouble saying that because there's nothing silver lining about the pandemic. But the decisions we're going to make to rebuild should be, and are, some of the same decisions we need to make relative to addressing the climate crisis and building resiliency, as well as reducing fossil fuels and greenhouse gases. And so let's do it all at once. And so some things that might have taken 3 or 5 years to move forward on climate now may move forward in 12 months, because we are making big investments, maybe with money we don't have, but we've got to do something to move forward and follow the guidance from the economists to move forward. And in those contexts, COVID and climate change are two sides of the same coin.
Silver lining is not a phrase that I've actively tried not to use. I think anytime there's a tragedy or a great societal upheaval, you just try to learn from it so that you don't repeat it. So I appreciated how you wove together all of the things you said you were not an expert on. And I think I would hazard a guess it's because the structure of the Maine Climate Council has looked at all of those things. And you all have done an excellent job as an outside observer talking to each other about the different perspectives and trying to weave it together. Do you think that's a fair assessment?
Oh, I think that's a fair assessment. The Climate Council process has been compressed in time. We didn't do a lot for a few years. And then Governor Mills in 2019 put forward this legislation that established the council and a process to move to the development of the sort of the first integrated Maine Climate Action Plan that's due this December, and then every 4 years thereafter. So this ongoing initiative, but first time out, everything has to be done. And so we have, the council is got 39 members that are on the council itself, but it's supported by a scientific and technical subcommittee to essentially assess the state of science of climate change impacts on Maine, and then 6 working groups that run the gamut from transportation, energy, and infrastructure, and things that you might more often think of relative to climate, and are more focused on mitigation, but not solely by a long shot, to communities and natural working lands and marine ecosystems that are a lot about adaptation, but also a strong component throughout there on mitigation. That was about 230 people throughout all of those working groups that met, I'll say regularly, since last fall, to come up with a set of strategies that were delivered to the council in June. So those were a deep dive, really complex. A lot of other people contributed to participating, providing input. There's thousands of pieces of information now from our Maine community that have been submitted. I forget what the number is, but it's a big number, to the Maine Climate Council website that's calling for input. I think we're in the process, or the council's in the process of intake now, as the information gets funneled to this initial delivery date of December for the action plan. And obviously not everything's going to be solved in December. It's kind of the low-hanging fruit, the high priority, also identify things that need to be developed or need to be figured out, et cetera. As our governor said in her or a number of times, we've got a lot of reports. She said no more reports. I shouldn't really mean that. We'll still do more reports, but it's time for action, and there's no question it's time for action. So there's going to be a lot of pressure to make meaningful decisions about both building a mitigation strategy that reaches the targets of 45% reduction in gross greenhouse gas emissions by 2030 and 80% by 2050, with carbon neutrality in 2045. Talk about the technical nuances of how they're different, but basically get out of the business of fossil fuels as fast as we can. And at the same time, build resilience, which is sort of a climate change wonky term, but that means, in all different sectors, what are the things that we need to do to minimize negative impacts from climate change? And, again, the science there shows that, a dollar spent now in an informed way is cheaper than waiting for bad stuff to happen and then having to repair, recover, lose crops, or suffer disease. So that's the focus of what's going on. So yes, I think a lot of the deep thinking and integration. Oh, and of course, in the middle of all this, we get a pandemic. And so I would argue, we've seen a lot of this around us in Maine and in society, but we get a pandemic, and this entire process where people are going back and forth to Augusta and having conference calls, and every day there was stuff going on. Suddenly it all moved to the web, it all moved to mostly Zooms, but it kept right on going. And so, there was a lot of Zooms going on, but there wasn't a lot of loss of momentum. Probably the thing that was most difficult was to get input from the public, stakeholder input, because you couldn't have town hall kinds of meetings and things that were planned, which we were just getting to the point, collectively, where strategies were in their sort of very draft but initial phase, and so people could respond to them. And so all of that it both got postponed and went virtual. But a number of different things eventually over the summer happened virtually, and the website's collecting input. So that's probably the thing that got most impacted by COVID. And of course, thinking about, how does the strategy going forward, how do the plans going forward, how do the investments for recovery going forward impact thinking around the combined climate, economic recovery, pandemic response, reaction of the state, because they're obviously all interrelated.
I want to switch gears just a little bit and give you an opportunity to talk about your work with students. Land-grant universities have a service aspect for the society and research, and the one thing we haven't talked about is students. And I'm pretty sure you have a devoted, if you're like almost every other faculty member I know, the students are actually the most important part of your work.
Yeah.
So I would actually like to give you the opportunity to talk about a little bit with how you do this work with both undergraduate students and graduate students.
So obviously, you interact with students in classes and they do projects and things like that, which is the heart and soul of, what we do on the educational part of being a university. I spent a lot of time I'm not one of the faculty that have lots and lots of classes. And so I've got a, high percentage of my research appointment and spend a lot of time doing that. A lot of us spend the greatest amount of time sort of interacting with our students. Two things for me is graduate students and students that work in my research program. And so graduate students some people are not really sure how that works, and different disciplines differ. But graduate students in my area, natural, usually, they're multiple year programs. They do a thesis, they do a major research project. We're out in the field sampling soils and trees and water and watersheds in different parts of the state. And there's laboratories, there's a fair amount involved in it. And then we write up the science and it becomes their thesis so that they can graduate and publish papers around that.
And it's all new, right? I think that's the part that is easy to forget. They're doing new work and new research that we don't know anything about.
Yes, because
they're building off of old. But
they're challenged to, in defining. I just had a Zoom with one of my students earlier talking about this, as often happens. But defining the state of knowledge. So what do we know? So here's a problem. I see it. We don't know what the answer is. Maybe it's in our backyard, but that doesn't mean no one knows the answer. So the first thing we do is go figure out, what do we know? What's society learned, whether it's in Russia or Europe or in California or here. You go to the literature to figure that out. And so now this is what we know. This is what we know for this problem in this location. And we're not going to be able to solve this unless we better understand whatever it is. That becomes the focus then of the thesis, to push back the frontiers of knowledge, which I like to tell them, and they just laugh.
That's so funny you say that. My husband's a researcher in physics, and I always, for a long time, it was like, go push back those frontiers. Yeah.
No, we do it every day.
Yeah.
It's a good thing. Usually in little. So the other thing people don't fully appreciate, in little tiny steps. Everyone wants to cure cancer. But the reality is science moves forward like a battleship, very slowly, point in the right direction, and you just keep moving towards solutions. Every now and then you hit this threshold and it's like, wow, that's amazing. But it's a very incremental process. That process that I just described, however, isn't done just certainly by me or the single graduate student. So the other part that's been a big part of my program historically has been undergraduate students that for their job work in my research program. And so depending on when it is, over the years, we've had, from 3 or 4 or 5 during the academic year that work part-time between classes, et cetera, to a dozen in the summer if we have a big research grant and a major sort of field campaign. Those students, they're getting paid to do a job, but they're also, working with us hand in hand. Sometimes the work that they do, they spin off into projects for classes and things like that. And, it's a thrill to be able to be part of all of that and help them in the class project part of it and what have you. And you do it for a while, and you also then have this population of people out there running the world that came through your program that still reach back to connect, but also reach back sometimes for, what's your input on this issue, or, could I call you to ask some questions about whatever, because I'm working on it in my job. So that's the part graduate students, undergraduate students, and alumni of the program out of both categories that are, it's a gift. They pay me to do it, I'll admit, but that's a wonderful part of the job. And, that's the population of people that is taking us into the future. And, you could argue how well a job we've done in giving them the world that they're inheriting, but we can work like hell to help them move forward to make it a better place.
Well, I think that is just about the perfect place to end.
Okay.
I actually, you and I have known each other longer than just this conversation.
Yeah.
When I was working at UMaine, I have always appreciated your work and your willingness to talk about your work and just kind of talk about the value of science. And, I think you're right. It's not science-based policy. It's policy that's rooted in science and taking into account other things. So I personally am deeply grateful for the work that you've been doing. I'm thrilled that you, again, like most faculty I know, enjoy the student aspect of it. It's kind of this hidden treasure, I think, that we don't talk about enough, and the value.
No, we don't talk about. That's true.
And I think it's really important. What you learn as an undergrad and a graduate student carries with you. And sometimes in my case, what you learn is you don't want to do that. And that's also important to have someone help support you through that. So I appreciate your work with this. I appreciate your work with the Maine Climate Council.
Well, back at you, Kate.
I cannot wait to, when this pandemic is over, we can all get together and talk about climate change in a broader piece again.
Absolutely. And we will. Much to do. Yep. Thanks a lot.
The Maine Science Podcast has received support from the Maine Technology Institute and is recorded at Discovery Studios in Bangor, Maine at the Maine Discovery Museum. The Maine Science Podcast is produced and edited by me, Kate Dickerson. I received production support from Maranda Bouchard, and the Discover Maine theme was composed and performed by Nick Parker.